What I'd like to do is, so Jason gave us a good, fairly deep technology overview on containers. So just to reiterate, the simplest way to think about containers is they're like VMs in the sense that they are abstractions, but they do the abstraction at a more granular level. So where in a VM environment, you've got a full replica of a guest OS that's being hosted by a hypervisor, whereas in a container environment, you've got more of the code abstracted and less of the infrastructure abstracted. So we're going to spend most of the remainder of the session talking about specifically Red Hat OpenShift Container Platform, which is kind of the de facto standard or becoming the de facto standard in the enterprise for container orchestration. And we'll also touch on some of the challenges and issues and best practices around architecting solutions for containerized and microservices environments. But I'm going to start off at a fairly high level. And
hey, Randy, just
yes.
for a quick introduction from a housekeeping perspective, my apologies for the interruption. But anybody who has questions, please place them in the chat, and we'll be addressing that at the end of the webinar. I know that we have a couple that have come in already, but just from a housekeeping perspective, just address your questions in the chat window, and we'll deal with those at the end of the webinar. And want to just also thank Jason real quick, and you can see why Tectrade is IBM, and IBM's one of the leaders in the clubhouse as far as the partners are concerned. So thanks, Jason, and Randy, take it home.
Great, thanks, John. But before we get too deep into the inner workings and machinations of containers, I want to use kind of a simple analogy. I do a lot of presentations like this, and a lot of our clients worldwide are just beginning their containerization journey, so they're still figuring out how it fits in the enterprise and how they can apply containerization technology. So there's kind of a simple analogy floating around that I've adapted a little bit for the purposes of this discussion. And it is based on pets, cattle, chickens, bugs, and snowflakes. So bear with me for a second. I'll take you through these and I'll explain what this means. And hopefully it'll give you a little better understanding at a more kind of visceral level what these things actually mean. So let's start with pets. Many of us have pets. Probably a lot of people on the call have pets. Pets are individual. They're members of the family. They have personalities. We care for them very closely, pay very close attention to them. You know, they live a fairly long lifespan. You know, they can consume a lot of your time depending on how many you have and what kind of a pet you have, whether you have a dog or a cat or something more exotic. They're pretty easy to take care of until you get too many of them, and then it becomes a bit of a challenge. And again, as you add more, the investment of time and energy required to care for them can become pretty intense and pretty onerous. So think of pets as an analog for bare metal servers. So the bare metal servers that are sitting in your data center fit this category. They're kind of very labor intensive, they're individualized, and they require a lot of your attention and effort. So now let's think about cattle. Typically, cattle exist in a herd. There's lots of them. They generally don't have names, although they may in some cases, depending on how many you have and how emotionally attached to them you are. If one of them gets sick or has a problem, you know, it ends up as dinner in most cases, or not, depending on the condition. You may or may not then replace it, depending on your production cycle and your business model. The life expectancy is shorter than a pet, typically. They also roam around in large spaces, individually, but in large spaces, and you typically monitor them as a group. So you don't always keep track of each individual head of cattle. You generally monitor the herd at kind of a macro level. So think of cattle as an analog for VMs. Sometimes they're sitting in your data center, sometimes they're sitting on one or more public clouds. So the next one, and this is where we get into the good stuff, so chickens. Chickens are much more efficient than cattle. You can keep a whole bunch more of them in the same or smaller space. They breed and reproduce much faster and more consistently. They have a shorter life expectancy than cattle. If you need to increase production, you can do so incrementally by simply hatching more chickens. So you can chickens scale very effectively. They also require fewer resources and in more granular units of allocation. So you don't have to go buy 50 metric tons of hay or feed. You can buy very small quantities and scale it incrementally. So chickens in the animal kingdom are the best analog for containers because that is the container model. Now, to kind of cycle back to something John said as well, and one of the themes of his discussion was really around microservices. So microservices are kind of like insects in the sense that they typically have a very short lifespan, sometimes only a few hours. By the way, this was the least creepy bug picture I could find, so hopefully you appreciate that I didn't get anything really nasty. They're functionally limited typically. They're sometimes necessary, sometimes they're annoying. You sort of have to have them, but they can be a bit of a pain. But they are lower level and very important parts of a broader ecosystem and food chain. You know, certain animals eat bugs, other animals eat those animals, etc. They pollinate plants, so they do serve a very valuable purpose. So insects are kind of serverless apps or functions as a service. So these are very small, you know, pieces of code or fragments of code that serve very specific purposes. So the last one we'll talk about, and this is kind of like what we want to try to avoid, are snowflakes. They're individually unique by definition. It's impossible to reproduce or replicate them. They're typically kind of fleeting, fairly ephemeral. The more you have, the more difficult they become to shovel and manage. And they're very delicate and they're very susceptible to environmental disruptions. So think of snowflakes as bespoke apps or servers which are highly customized, hand-coded, you know, hand-fed, and require tons of maintenance and are very difficult. This is the old world. This is what we want to try to get away from with containers. So going back to our architectural metaphor for containers, think of containers as chickens in that model, and think of VMs as cattle. Just kind of help you get your mind around the difference. So again, to build on what Jason said earlier, why are containers so important? So we do lots of surveys of global companies. We have obviously thousands of global 1,000 clients across the spectrum of industries around the world, and we survey them and gather data from them on a regular basis to understand where their thought process is, where they're going, where they're investing. Security solutions are always top of mind, but automated deployment and management of IT services, tools to accelerate dev, test, and production, and support for public cloud and on-prem environments are right at the top of the list for things that virtually every organization is thinking about, investing in, and planning for. Now, if you look at that from the perspective of what platforms are being most widely adopted, Docker and Kubernetes in particular are leading the charge and have been for quite some time, actually. They also, not coincidentally, formed the basis for the Red Hat OpenShift container platform, which is built on hardened distributions of Docker and Kubernetes, although it also supports other container frameworks, which I'll talk about in a second. So the message here is that containerization is growing very quickly. It's being adopted very widely. There are lots of open source projects floating around. You'll see some of them listed here, which have had varying degrees of success and adoption within the enterprise. If you want to implement the lowest risk, most widely adopted, you know, most robustly supported platform, OpenShift Container Platform is a great choice. It has been chosen by, you know, many of the Fortune 1000. It's reliable, it's stable, it's fully supported. It's got the full weight of IBM and Red Hat behind it. So it's a pretty safe bet. So OCP, you'll often hear OpenShift Container Platform referred to as OCP. It has really everything you need to achieve that architectural nirvana and that end state that Jason spoke about earlier. Enterprise-grade Linux operating system that underpins it all, full container runtime, full networking, monitoring and management, container registry, authentication. All the pieces are there, everything you need. You don't have to go become an expert black belt third-party integrator. You don't have to pull from 50 different open source projects and underwrite the risk of doing the integration on your own. It's all done for you and delivered in a package that's very easy to consume and manage. So the platform is built with speed, mobility, agility, elasticity, the ability to flex as demand changes. So you can spin down resources when they're not required. You can bring resources on board and do so very quickly as demand increases. And it's also programmable and composable, guaranteed to ensure platform independence. One of the big concepts that you'll hear a lot within containerization and microservices architectures is this idea of write once, run anywhere. So you don't have to code to specific individual platforms. So you get really a lot of the benefits that you get with virtualization, but at a more code element level. Faster time value and revenue, very flexible, very adaptable, and of course it provides a great integration platform for both existing and next generation technologies as they become available. So,
hey Randy, can I just stop you a second? A few people in the chat are saying that they're seeing the wrong slide.
Oh,
I just want to check.
Okay, yeah.
That everyone is seeing the right slide. I know a few people have said it.
Okay, yeah, right now the slide is transformation is underway is the title.
Which is what I can see.
Okay. Good.
Is anybody else not seeing the right slide?
This is the
I think
blessing and
a couple of people have got a glitch. I think most people are on the right one. Sorry.
Yeah.
Okay, you can carry
no,
on.
no worries. This is the blessing and curse of Zoom, right? In the era
Yeah.
of the pandemic. You know, peak times, unfortunately, it gets a little dodgy. I will say, however, and please correct me if I'm wrong, this is being recorded, so certainly the recording will be available as well as the content. So
Correct.
apologies
100%,
for any edge issues. Great, thank you. So just a little bit more research for those who are perhaps not convinced that the transformation and migration to containers is happening in full force. All of the major analyst houses, you know, Jason came from Gartner, so obviously he spoke about this early on. Enterprises are looking constantly for ways to transform the way they develop and release software and services. They want to be faster, more agile. Containerization is a great new standard for both hybrid multi-cloud deployments and kind of rapid time to market. So, you know, DevOps, 90% of organizations are going through some kind of a DevOps transformation or are in the planning stages. It's typically fairly mature. 90% of enterprises will use multiple cloud services. This is kind of an interesting one and another reason why platforms like OCP are so valuable, because they're designed to support multiple public clouds. And as your organization becomes more integrated into the public cloud, it's very unusual that you'll have a single cloud provider. Most organizations have multiple. There was another study as an addendum to this one, which found that within the Fortune 100, I want to say the number was about 70% reported using 5 or more public clouds as part of their production IT infrastructure. So obviously being able to integrate that many disparate cloud platforms becomes a really important best practice. And application platforms, 60% are considering private cloud and or hybrid cloud as being critical within the next 12 months. And by the way, this survey data is from early in 2020. So clearly this trend has continued unabated. In fact, in many ways, one of the, you know, I don't want to say positive impacts, but one of the impacts of the global pandemic has been a much more aggressive push towards this kind of containerization technology. So one of the things that tends to be or can be an inhibitor to containerization is how you do data management. And the simple reason for that is containers were originally conceived to be stateless. They were designed to be ephemeral objects that, you know, were brought online as needed. They did some work, they processed some information, and then they went away. So they were elastic, they were on demand. So because they were stateless, there was no expectation or design pattern which required that they have data that is persisted from one session or one state to the next. So you didn't have to worry about kind of managing data or managing stated data. So if the container went away and reconstituted, there was never any reference to data that lived outside of that contained entity, that sort of declarative entity. So as containers became more widely adopted in the enterprise, of course, this started to create some real limitations. Enterprise applications are almost always to some degree stateful. They require persistent storage that can survive from period to period, can cross functional boundaries. So persistent volumes and the ability to attach to persistent volumes became very, very critical. Now, this has created a set of challenges around how best to bring these two things together. So this kind of ephemeral design pattern of stateless containers and microservices and the more stateful kind of enterprise-ready storage array. Furthermore, as with traditional workloads, there are still requirements for multiple protocols or multimodal access. There will be workloads that will require block level access. High performance databases are a classic example of this. File access is, of course, very important depending on what sort of a use case, and object is becoming more and more prominent. Now, to further somewhat complicate matters, each of these individual modalities itself requires different container operators and container metaphors and access modes to make it work. So when you factor all this together, the point here is that it's another reason why you want to be very careful about selecting your environment and kind of plot your course wisely as you think about adopting containerization. Now, given that we've talked about some of the challenges, you know, the occasional question we get is, well, why would I want to do this? Given the risk, given the complexity of the integration, why do this? Well, the answer is because you get a huge efficiency and economy of scale by decoupling your infrastructure and making your infrastructure capacity consumable in smaller increments. So you can take an idea and you can, you know, through an efficient agile DevOps process, get to an end service that you can then deploy to your end users and your constituents much faster, much more repeatably, much more reliably, and you can then manage and sustain it similarly in a much more efficient way. So despite the challenges associated with integration and architecture, the benefits far outweigh the risks. So in a hybrid cloud model, you get all of the advantages that come along with containerization of microservices and hybrid multi-cloud architecture, and it will also support your traditional workloads as well. One of the other interesting things that is happening as a result of this trend towards more containerization is it's giving rise to new skill sets. So if you look back even a few years ago, a lot of development was, and has been for some time now, often pushed offshore. So there are organizations, outside the US and all over the world that specialize in doing spec development and creating bespoke applications and workloads based on a set of requirements, which are documented as a collaborative project. As organizations are adopting more of a true open standards-based hybrid multi-cloud architecture, it's creating a need for resources typically in-house that are really less application programmers and business logic programmers and more infrastructure programmers. So they're responsible for provisioning, managing, allocating, sustaining, designing the infrastructure, and then exposing that infrastructure in the form of APIs that can be programmed to and consumed by users and developers. So this is an interesting trend. It's continuing to grow and will continue to grow as hybrid multi-cloud becomes the de facto standard deployment model across the enterprise. So it's both an opportunity and a challenge, because people that have this skill set, there aren't a million of them floating around. They're a fairly scarce resource. They're not always easy to find, but it is a skill set that organizations are both seeking and also investing in. So very important. So let's quickly go through some messaging around kind of our philosophy, the IBM Red Hat philosophy, on where all this fits, and kind of tie it together at the end. So we view enterprise transformation and hybrid cloud as being comprised of cyber resiliency, which is obviously critical to everything we do, advanced data services and operations, which take full advantage of things like automation, machine learning, either at the application workload level or at the infrastructure level. If you look down at the bottom, you'll see a bunch of different infrastructure platforms, both on-prem and cloud, as well as VMs and containers and everything in between. Our goal is to provide a very rich data services layer that sits between your workloads and your infrastructure and provides an open standards-based single global namespace, very flexible data services layer to support whatever it is you're trying to do. For those who are familiar with IBM's deployment model, we have these things we announced early last year in collaboration with our Red Hat partners called Cloud Packs. They are pre-integrated bundles of software, all based on Red Hat OpenShift Container Platform as the orchestration layer. Now, I won't go into a lot of detail on these. We can certainly have a follow-up, but the Cloud Packs are targeted at different environments. There's a multi-cloud management one. There's one for application development. There's integration. Data is for big data analytics and AI workloads. And of course, there is a security-focused one as well, all based on OCP, all providing a common stack integration upward into the control plane. But just as importantly is the ability to do the downward stack integration. In other words, as your environment considers, or your organization considers deploying multiple workloads in a containerized model, having a common set of data services on the back end makes it significantly easier to manage. And this is where a companion technology called Red Hat OpenShift Container Storage comes into play. So just like OpenShift Container Platform provides the orchestration abstraction layer, OCS provides the data services abstraction layer. So here's a few examples, and this is just a sample of different types of workloads. So for example, I'll choose in Cloud Pack for data, we have a lot of organizations that are running ultra high performance, low latency DB2 warehouse solutions. Those DB engine pods, which are running inside OCP, connect via OCS to back-end infrastructure, either a shared file store or block volumes sitting on your existing SAN. So the point here is to kind of take the previous view of the world and make it a little bit more specific. So kind of tie it down. And as we get into Frank's section, he'll give you some more examples of where this plays out specifically on client sites. So again, our philosophy is working together with Red Hat. to provide a platform that supports a wide variety of infrastructure. And we're showing some of our solutions. Of course, it works with others as well. A very robust, comprehensive, hardened, enterprise-ready, software-defined storage and software-defined infrastructure portfolio of solutions across scale-out, high-performance block, file, object solutions, cloud services, a very robust virtualization and abstraction layer, whether it be for straight real-time heterogeneous virtualization or backup and archive, and finally, a full suite of management tools integrated into the Cloud Pack architecture you saw earlier, as well as into your current data center environment. So it's a complete end-to-end solution stack with the IBM software-defined Spectrum storage portfolio. Now, this technology is in use, as I mentioned a little while ago, across many organizations, thousands worldwide, across a wide variety of industries and use cases. Some we can name, some we can't. There are very large kind of global 100 organizations that generally don't allow their name to be used publicly. The first one is a large multinational resort chain that is using our software-defined storage solution and our StoreWise now flash systems arrays. They have been rebranded, as well as some of our tape technology to achieve a very agile, high-performing, highly scaled platform that does intelligent tiering and ILM that allows them to store hundreds of petabytes of data in the most economical way without sacrificing performance. I talked a minute ago about our Spectrum Scale product. Spectrum Scale is our ultra high performance clustered file system. It is currently being used and this changes from day to day because it's kind of dynamic, but in the top 500 fastest supercomputers in the world, Spectrum Scale runs 11 of the top 20, including the top 2. The point here is that it's hardened, proven, scales exceptionally well, delivers amazing performance. So we also are very keen, working with our partners like Tectrade, to make this technology easy to consume. So you don't have to go, again, do this massive integration. You don't have to put all the pieces of the puzzle together yourself. We have as an offering, and this is just one example, something that we're doing this year, where you can bundle our enterprise leading flash system, in this case, the 5200. You get a base configuration of the 5200, which can deliver up to 460 terabytes of capacity in a single 2U box that comes bundled with OpenShift Container Platform, as well as the storage suite for Cloud Packs, which you saw a few moments ago, and our Spectrum Protect Plus solution for data protection and archive, all in a single bundle with all the entitlements wrapped into it. Very easy to consume, a great sort of plug and play solution to begin your journey towards containers, or perhaps extend an existing container environment. And we're happy to, of course, tell you more about this if there are any specific questions.